define where these graphs come from. Okay? We learned about the unit circle, and we learned how at 0 degrees that coordinate is 1, 0. At 90 degrees it's 0, 1. At 180 it's negative 1, 0. And at 270 it's 0, negative 1, and then back to 360. And then if you continue going around, those values just keep repeating over and over again, right? Right? Well, we also learned that your x value represents the cosine, and your y value represents the sine. Remember? So if I took these on this graph right here, the cosine and sine graphs all together, so it creates a big circle. But if I separate that into two separate graphs, right here, let's do our sine graph, okay? Where your x-axis represents the angle, and that can either be in degrees or radians. And your y-axis represents the output. So your x-axis is the input, that's your angle. So if you said sine of 0 degrees, the y-axis is your output. Okay? So what we're going to do is we're going to look at our unit circle and write these two separately so that we can graph it on here. Now I know you see it already graphed on the board, but let's do it right here manually. Okay? And so this x represents the degrees. That's theta. Okay? And so when theta is 0 degrees, if we're just talking about sine, when theta is 0 degrees, now all the sines are your y values, right? So at 0 degrees, sine is 0, right? Now, you could put that in your calculator and see that also. You just have to make sure that you're in degree mode. So if you said sine of 0 degrees, you would get 0. Sine of 90 degrees is what? 1. Sine of 180 degrees is back to 0. Sine of 270 is negative 1. And then you go back to 360 and sine is 0. Okay? Because 0 degrees and 360 degrees are at the same spot. Right? And so the sine and cosine graphs make a wave. And it just, as I go around that circle, that just continues. That wave just keeps continuing in both directions. If I did negative angles, it would continue in the negative direction. Okay, that wave never changes. We learned a little bit about some transformations. And in our standard graph of sine, the number in front of here, normally that would represent a vertical stretch or compression, right? Well, it still does. It still represents a vertical stretch or compression. If it's greater than 1, then it's going to stretch the graph vertically in both directions, symmetrically, okay? If it's less than 1, meaning, I don't mean a negative number, I mean 1/2, or any fraction between 0 and 1, it's going to compress it. It's going to push it down like this, but symmetrically from bottom and top. And so if it's negative, what do you think it would do to it? Reflect it. If it was negative, it would be a reflection. Now, we're not going to be dealing with reflections. We're just going to be dealing with stretches and compressions. But if it's 1, it's the parent graph. It's just normal. It's not transformed at all. Okay. The number right here represents, now we haven't dealt, well, you might have in math too, but the number multiplied to x, multiplied to your angle, or multiplied to theta, because x represents theta. The number multiplied to it, what it does a horizontal stretch and compression. It either pulls it like this, or it pushes it in. And we talked about when we had to name the center of a circle, and we had to name things like that, I said if it's in a grouping symbol, it's the opposite of what you think. Right? Right? Like when we did the center of a circle, it was x minus 5. That meant positive 5. Right? Well, same thing here. So we normally think of a number bigger than 1 being a stretch, and a number less than 1 being a compression, but it's the opposite if it's inside these parentheses. So if that's bigger than 1, then it's actually going to mean it's going to push it together like this. So instead of being all nice and spread out, it'll be like that. And if it's a fraction, if it's less than 1, it's going to pull it like this. So the waves will be like really far out. Yes. What about B? Yeah. How it affects the graph. And K, what do you think that means? Up and down. It shifts the whole graph up or down. Okay? Now, we're not shifting left or right. We don't do that in math 3. Okay? So we're only going to shift it up and down, and then we're going to stretch and compress it this way and this way. Okay. So let's fill this in. So 0, 0 starts right here. Now, what I'm going to draw right now is one wave. One wave is called the period of the graph. Okay? It's from the start of one wave to the end of one wave. Okay? So, 90 degrees is 1. 180 degrees, back to 0. 270 degrees is down to -1. 360, back to 0. So your sine wave always starts at 0 if it hasn't been transformed at all. Sine starts at 0, it goes up, back to the x-axis, down, and back to the x-axis. And that represents one complete wave. Now, like I said, if I kept going with that table, it would continue back this way and this way. Okay? But one wave, because it's not transformed at all, stops at 360. So my period is 360. The period represents one wave. Okay? These problems are going to ask you to tell you two things, the amplitude and the period, and then you're going to have to graph it. The amplitude is this right here. The amplitude changes the height of the graph from the origin. Normally, the parent graph is at 1, because that's just 1. But if this was 2, then it would go up to 2 and down to -2. It's symmetrical. Okay? We call this the line of symmetry. We call that the midline, because it's in the middle. Okay? The only time that midline changes is when? How would this midline change? When what? When K changes. Very good. If it gets shifted up, that midline gets shifted up. Okay? And so if this was +2, if you had to graph this, first thing I would do is graph where that midline is. So if this was, let's say for this graph purposes, this was +1, my midline would now be here. The amplitude, if it's just 1, then you would go up 1 and down 1, and you'd have to graph it like this. Okay? So graph that midline first, and then you can graph the rest from there. Okay, so let's do the same thing with cosine. Cosines are our x-coordinates in our unit circle. Okay? And so at 0 degrees, cosine is 1. What is cosine at 90 degrees? 0. What is cosine at 180? What is cosine at 270? And what is cosine at 360? Okay, we come back to home, right? So cosine, sine starts at 0. Cosine starts at 1. Cosine starts the maximum. Yes?
Cosine is x.
Is. My x value is right here.
Then why'd you put in the y?
Oh, because this is the graph of cosine theta. Right now, x is theta.
Okay.
So this is just cosine theta by itself. This graph has both cosine and sine together. So this is, we're separating the two and graphing them along the same axis. Okay, so 0, 1, 90, 0, 180, -1, 270, 0, and 360, 1. And so, but it keeps going. Okay? It keeps going in both directions. But the cosine looks like a U. One wave. It starts at the high, goes all the way down to the low, and back up to the high. Okay? And the same transformations happen with cosine. Okay? Your midline, if it's not transformed, is at the x-axis. And it's symmetrical. So my maximum for sine is 1, and my minimum is -1. And same thing for cosine. Okay? Any questions? Okay, so amplitude is that A. Amplitude for parent graph is 1. Amplitude represents how high and low your maximum and your minimum of the graph. Period. Remember, I told you the period is 1 cycle, right? The period is 1 cycle. So if it's not transformed at all, then 1 cycle stops at 360 or 2 pi, depending on whether you're in radians or degrees. Okay? But if it is stretched or compressed horizontally, that period is going to change. Okay? Okay, so you remember I told you that the number multiplied to x tells you whether it shrinks it or compresses it horizontally. Okay? What that number also tells you is the number of waves that exist between 0 and 360. So if this was 2x, then there would be 2 complete waves going from 0 to 360. The period is where the first wave stops. Okay? So this tells you the number of waves between 0 and 360. And you might see a problem that'll say, graph cosine of 2x. And then it'll say, theta is between 0 and 360. So that means it wants you to graph, if it was cosine of 2x, you have to graph 2 complete cycles, because you're going to go until you get to 360, or that should say 2 pi. This should say 2 pi. Okay? So if they specify these parameters, then you have to keep graphing it until you get to the end. Okay? But on your homework, I'm going to specify graph 1 cycle. So you're just going to graph 1 cycle. So you have to just figure out where 1 wave ends, and you'll stop there. Graph just 1 complete wave. Okay? The way we do that, if B represents the number of waves between 0 and 360, and I want to know where the first wave stops, you just take 360 and divide it by whatever B is. Right? If it was cosine of 2x, B is 2. So we do 360 divided by 2. So the first wave stops at 180. And then if you had to keep going, you would keep going and do another one all the way to 360. Does that make sense? So if this is greater than 1, then that represents a compression horizontally. It scrunches it together. So you're going to have more waves, right? So my period is going to be shorter. Does that make sense? From beginning to end of 1 wave, it's going to be a shorter because you have more of them in there, scrunched up in there. Okay? But if it's less than 1, say this was 1/2 times x, then it pulled it horizontally. It stretched it out horizontally. Okay? So I'm not going to have a whole complete wave between 0 and 360. So if I have to graph a complete wave, let's say it was 1/2 times x, then it would be 360 divided by 1/2, which is 720. So you got to go all the way to 720 degrees before you get 1 wave, because it pulled it like this. Does that make sense? Okay. Now, your calculator, you can check your graphs on your calculator, but when you put in, first you need to make sure that you're in the right mode. If it needs it in degrees, you need to make sure you're in degree mode. And then you need to, when you zoom, you need to do zoom trig. Because zoom trig will adjust that window to where you can actually see the wave. Okay? So, this is what was on the board. Let's look at, first let's just state the amplitude and the period for each one of these. Then we'll graph some problems. Now, do you see a degree sign anywhere? No. So this, you are to assume that this is radians. Okay? If you don't see a degree sign, then you have to assume it's radians. So what's A in this problem? 3. That's my amplitude. So my amplitude is 3. That means from 0 on the x-axis, the highest point is 3, and what's the lowest point? -3. Okay? The period is the length of one wave. So it's not, how many waves are there between 0 and 360? 2. So when we want to find out where the first wave stops, we have to do 360 or 2 pi divided by 2. It's either 360 or 2 pi because they're the same thing, right? So those cancel, so my first wave stops at pi, which is the same thing as 180. Okay? So it compressed it and it put 2 waves in there between 0 and 360. All right? Now,
How do you know for period whether it's too wide or not?
if it doesn't have degrees anywhere, then just do 2 pi. It'll specify on your homework. The instructions will say find this in degrees, find this in radians. It'll specify. Okay. All right. What's the amplitude in this one? Okay. That means it goes as high as 6 and as low as -6. So it stretched it like this. It made it really tall. Okay. And the period, it's 2 pi divided by 1/6. So what is that actually? No, that is not 1/3. 12 pi. It was 1/3 if I was multiplying times 1/6. But dividing, remember when you divide fractions. So that's 12 pi. Okay. If you had to do 360 divided by 1/6, you're really multiplying 360 times 6. Okay. So I showed you that so you could refresh those elementary dividing by fractions skills. Okay. Okay, so this says using degrees. So using degrees is going to tell you how to set the axis. Now, on the worksheet I'm going to give you, all the degrees or radians are already marked on there. You just have to figure out where it starts and where it stops and where it crosses the x-axis. Every wave is divided into 4 equal sections. Okay? Every wave is divided into 4 equal sections. So, figure out where it ends, take that number divided by 4, that'll tell you where to put your hash marks. Okay? So, amplitude. What's the amplitude? 4. So, first thing I'm going to do is I'm going to take this graph and I'm going to do this. That gives me my boundary that I know I can't cross. That's the highest point. And then my lowest point is -4. Let me back up a second. Before you do that, you want to make sure that it's not shifted vertically at all. Because if it's shifted vertically at all, then that is not 4 and -4 anymore. Okay? And I don't have any plus k. So that means my midline is 0. Okay? Now, how many cycles are there? How many waves are there? from 0 to 360? 1/2. This is 1/2, right? So B is 1/2. So if we want to figure out the period, we have to do 360, because it's degrees, divided by 1/2. Which is equivalent to what? 720. So one wave stops at 720. Now, so 720, I'm going to know, I just do this. Not everybody does, but I do, because I know that's where I have to stop. That's where one full wave stops. Okay? So, it's divided into 4 equal sections. So I do 720 divided by 4. And I get what? 180. So each hash mark moves 180 degrees. Okay? So, there's the first one, 2, 3, 4. Now, some of these, when you divide it by 4, your graph, you may have to estimate where it is. Okay? It doesn't have to be exact. It just needs to be an estimate. So I can figure out where to put these hash marks. Because when I go to graph it, I have to do, see, we're doing sine, so I have to start here, then I have to go high, here, low, here.
Is it correct?
It's, yes, because there's 4 equal parts in one wave. Okay? Now, that was the hard part. The easy part is just graphing. You just have to remember that sine starts at, I say sine starts at home. Sine starts at 0. Then it goes max, 0, min, 0. Okay? Starts at home. Sine and cosine, they are very, very similar, except that cosine starts at the max. And then home, min, home, up. So, this is sine, so we start at 0. Maximum, 0, minimum, back to 0. So the only difference is where they start. It follows a wave. You go high, home, low, home, high, home, low, home. Or 0, if you don't want to say home, say high, 0, low, 0, high, 0, low, 0. Except that sine starts at 0 and cosine starts at the high. Okay? Any questions? We're good? Let's do another one. Now this one's in radians, so you notice my x-axis, my angles are in radians. Okay? So my amplitude, that's always easy. First of all, is it shifted vertically at all? No, I don't have any plus anything. So that means my midline is going to stay at 0. And then my amplitude is what? My amplitude is 3. So that means my maximum values are 3. And my minimum values are -3. Okay? Now, all I'm doing now is I'm figuring out where does it stop and where do I put my hash marks. Okay? So, my period is 2 pi divided by b. What's b? 4. So it's 2 pi divided by 4. And so that's pi over 2. Okay, so that's where one wave stops, pi over 2. So we'll find this. Here's pi over 2. So when I draw my one wave, I'm not going to go past that. Okay? Now, I have to figure out where my other little hash marks go. Now, we're going to figure out where they go. I see 1, 2. A lot of times it's easier to figure out where the halfway mark is and then divide those two into 2 equal sections. This is the halfway mark, right? So one has to go here and here. I don't need you to go label those in between pieces. This is just an estimate of where they go. Okay? Yes. Yes, you have to have, from here, you have to have 1, 2, 3, 4 equal pieces. Okay? Now, this is sine, so where do we start? At home, at 0, right? So, 0, then at the next hash mark, it's our high, then the 0, then low, then back to 0. Sine starts at home and ends at home. And you want to represent that it does keep going in both directions. Okay? So you see what happened was, it got stretched vertically. See how it's like really tall? And then this compressed it. So it's like an accordion. Okay? Any questions? See, if I went all the way to 2 pi, this would repeat itself 4 times. If I went all the way to here, I would keep going back again, and it would repeat. That cycle would repeat 4 times. You have 4 waves from 0 all the way to 2 pi. Okay? Any questions? Okay, let's do numbers. Using degrees. Now we're using degrees. Find the amplitude and period and then graph. What's the first thing that jumps out at me? It got shifted vertically, right? So my midline isn't at 0 anymore. Now it's at 1. My midline is now there. So when I do the amplitude, my maximum and minimum, it's going to be from the midline. It's not going to be from 0. If you do it from 0, it won't be symmetrical anymore. Okay? And so my amplitude is what? My amplitude is 1/2. That means from the midline, it goes up 1/2 and down 1/2. Well, this is the whole one, so up 1/2 and down 1/2. You with me? Okay. And the period. We're doing this in degrees, so it's 360 divided by what? 1/3, which is equal to, no, we're not dividing by 3. Oh, yeah. Okay, so 1080. 1080 degrees. So this is where one way stops. Okay? Now, you can take 1080 and divide it by 4, and you'll get so each hash mark goes 270 degrees. Okay, so from 0, you would go to 270, but I don't see 270 marked. So what I would do, if it's me doing it, I would count. It has to be 4 equal pieces, right? So we say 1, 2, 3, 4, 5, 6. So 1, 2, 3. This is the halfway mark, right? And then if I take this and divide it by 2, it has to be right there. Right? And then take this and divide it by 2, it has to be right there. What did I do? And so now, cosine, where do we start? We start at the maximum, we start at the high, right? So, this is my high, right here. high, then we come right here, high, medium, low, medium. Oh, that's too high. And go before this. Okay. Okay, so technically this shouldn't go higher than the maximum. So it shrunk it this way, and it stretched out, and it raised it up. Okay? Any questions? One more, and then I'll give you your worksheet. All ready? One more, where we have a vertical change, amplitude, period change, and it's in radians. What's the amplitude? Okay, I'm not going to graph it yet. The period. So it's radians, right? So it's 2 pi divided by what? 4. So the period is pi over 2. Okay. It got shifted. My midline moved where? Good. My midline moved down 2. So here is my new midline. Okay. Huh? Okay, so the amplitude goes up 2 and down 2, right? From the midline. So it goes up 2, so this is the highest point. And then it goes down 2, so this is the lowest point. And we said that one wave stops at pi over 2. So that's right here, right? Okay. One wave stops there. So if I'm going to divide from here to here into equal pieces, this is the middle, and there's my other. Divide it in half, and divide each section in half. Okay? And so this is sine. So where does it start? It starts at, right, at home, at the middle. So we go here, then where? High. Then where? Then where? Then? Good. Okay?